This is day 2 of applying slope, parallel, and perpendicular to solve real-world problems. If you haven't watched day 1, make sure that you watch that lesson first. To begin, I need to make sure that you kind of have an overview review of the special types of quadrilaterals and triangles. Particularly just knowing that, for instance, a right triangle has one right angle. And you can see that the two sides are perpendicular to each other, and we're going to use what we learned about perpendicular to prove that something's a right triangle. In the same way, we could also use the properties of the slopes of parallel lines to prove things about a rectangle. Opposite sides are parallel. Maybe a trapezoid where the top and the bottom are parallel. Different things like that. So this is a good sort of overview. You won't use all of them, but the basics are listed here. Let's look at an example together and then learn from this example. So we're given a triangle with vertices. That's the corners of the triangle, vertices. That's plural for vertex. Point A, point B, and point C. So this is already graphed for you. But if it wasn't, go ahead and put the points they give you into Desmos and make sure that you check the box that says label them. That way you're looking at exactly the points you need. You can even call them A, B, and C in your labels. So the question is whether triangle ABC is a right triangle. Okay, a right triangle has one angle in it that's a right angle. It looks like this is a right triangle, right? So that's where you want to start. Look for which kind of corner of the triangle looks like it's a right triangle. These don't. They're acute angles. They're narrower than a right angle. But this looks like, if I held up a piece of paper in this corner, that it looks pretty good. So what I want to do is find the slope of this line and the slope of this line. And to do that, you're going to count on the graph, rise over run, because slope is rise over run. And when you have a graph, that's the easiest way to determine the slope. So you have to start at actual points. You can't guess about points that are like halfway between. But we have 2 points that we can use. So to find the slope of the line AC, we're just going to count rise over run. We'll start here, and I go up 2 to get even with that other side that I'm heading for. All right, so that's my top number. So the slope of AC up 2 is a positive 2, and then I'm going left. 1, 2, 3, 4, 5, 6, 7, 8. I'm going left 8. Left is negative, and I can simplify that fraction to negative 1/4. Notice when you have a negative, it's either at the top or the bottom or somewhere in the middle here, but don't put it both places or that changes it, because a negative over a negative is positive. All right, now let's find this side. We need the slope. So again, we're going to do rise over run. It doesn't matter which one you start with. When I say rise, it could be lower. Okay, I'm going to start here, and I'm going to go up till I'm even with the other point, and then start counting my run. So rise, 1, 2, 3, 4, 5, 6, 7, 8. I'm rising 8. I'm now doing BC. Rising 8. And that brings me, where was I? Right here. And then I go right 2. Right is also positive. 8 over 2 is 4 over 1, or just 4. I'm leaving it this way because I want you to notice the relationship here. These are opposite. One's negative, one's positive, and reciprocal. The fraction is flipped. Opposite reciprocal slopes mean that the lines that we're looking at, that we found the slopes of, are perpendicular. And I can use my symbol for perpendicular, right? Remember the symbol? And so that means ABC is a right triangle. Find the slope, look at the relationship between them, and if they are opposite reciprocals, you have perpendicular lines. All right, here's another one, and this time I want you to try it. You're going to do the same thing. Decide which angle, which piece of the triangle looks like it's a right angle. I would say this one right here at C looks like it's a right angle. So you're going to check the slope of side AC and then check the slope of side BC. Are they opposite reciprocals? If they are, that means you have perpendicular lines, which tells us that that's a right angle and this is a right triangle. Go ahead and prove it now or disprove it, and then come back and check your work. All right, check your work. I color-coded here a little bit using arrows so that you can see how I counted my rise over run. Be prepared to ask me any questions that you have in class. What ended up happening was that the slopes of my lines were opposite reciprocals, and that means that this side AC is perpendicular to, look at the symbol, this side BC, which tells us that triangle ABC is a right triangle, and it proves it. It doesn't just look like a right triangle, it is absolutely true. In this next example, we need to prove that these points form a trapezoid. So you're going to start by putting these points in Desmos. All right, I've put in my ordered pairs. I checked the label box, and I even named them A, B, C, and D, just the way the problem had listed. So here are my points, and if you can imagine connecting them, this does look like a sideways trapezoid. It appears that this side, BD, is parallel to this side, AC. So if we look at the slope of BD and we compare it to the slope of AC, if those lines are parallel, what could you tell me about their slopes? They should be the same, right? Well, we have vertical lines. So when you find the slope of a vertical line, let's start at D, you go up, in this case 10, right? All right, that's our rise, up 10. But then we don't run, do we? We're there. We don't go anywhere. It turns out that vertical lines have a slope that we call undefined. And that is true of every vertical line. The same thing happens here. We go up 4, but we don't go left or right. And so we call that undefined as well. Because they're both undefined, They're both exactly vertical lines. They are parallel, and we can write that as AC is parallel to BD. And because they are parallel and there are 4 sides, we meet the requirements, and this proves that this is a quadrilateral. Or sorry, a trapezoid. All right, I want you all to try this one. You're going to do the same thing that we just did. You might need to sketch in the trapezoid yourself if it does look like one. Which 2 sides appear to be parallel, and then check the slopes of those sides. Remember, if they are parallel, the slopes will be the same. And so if they are, it proves this is a trapezoid. Go ahead and pause, try the problem, come back and check your work. All right, I plotted my points. I labeled them R, S, T, and U. And when I connected them, I could see, and it's much easier if you draw on it, that it looks like this trapezoid, if it is one really, has a top and a bottom at RS and UT. So if those 2 lines are parallel, then I can say for sure that this is absolutely a trapezoid. So I found the slope of RS. I had to go up 1 and right 2. And I found the slope of UT. I had to go up 2 and right 4, which simplifies to 1/2. Our slopes are equal. That proves that since there is one pair of parallel lines, that this is a quadrilateral. A trapezoid. I keep doing it. A trapezoid. The last thing I want you to do is fill in the missing words here. Be careful. We'll go over it together in class.